Hi, I'm going to go through the analysis now for this task with the balanced wooden strip, the CIE Advanced Practical Skills 1 paper from 2016. So we had this wooden strip, we collected mass, length of the spring and angle data for this wooden strip. The instructions also told us to include a column for m sine theta, so that's the mass multiplied by the sine of this angle. So these were already calculated for me, these are raw measurements. So if I click into this cell here, what have I done? The function is, ignore the if logic. The if logic was just to keep things tidy for myself. So if this was blank, it would return a blank. Otherwise, what it would do is multiply the mass, which is in kilograms, by sine of this angle. Since I was putting the angle in degrees, I needed to convert it into radians, so that's the reason for the additional radians calculation. I will make this spreadsheet available, so if you do want to download it, if it's helpful, then you can do so. It's a numbers spreadsheet, I'm not doing any conversion to Excel. So yeah, if you've got an iOS device, it'll work, otherwise you can ask someone to convert for you nicely. Okay, so yeah, that's this column here. So let's get rid of the keyboard now. So that's my data. The graph we had to plot is as follows. If I zoom out a little bit so we get a better view of the graph. So on the y-axis we plotted the y data, as in the distance y or length y, that's what's going in there. And then we had to plot m sine theta on the x-axis. Sorry, dump truck going by, very loud. So as I was saying, on the y-axis we have y, the length of the coils on the spring, and on the x-axis we have m sine theta, which is this fourth column. And as I noted, we were getting a nice straight line return from my graph, so that's good. Obviously, as part of the skills task, you'd have to plot that graph. I have done other videos on plotting graphs and graph stuff, so look that up. Also, I've got like worksheets that you can improve your graph skills with. So yeah, I'll put links to those in the description. But this was my graph that the spreadsheet automatically plotted for me with a straight line of best fit there. And this is the equation of the line. So once again, I'm shortcutting, calculating the gradient and the y-intercept. Those are skills you've hopefully acquired by now. If not, you need to do practice on that, and you will need to do it manually when you're doing this under assessment conditions. So if I zoom in on that, so we can see what those values are. The gradient is 0.1593, and the y-intercept was 0.0188. So we're going to write those down, and then we're going to answer questions on those. Let me pull up my answer sheet here so I can write these in. So the gradient is 0.1593, and this is 0.0188. Okay, let's flip over to the answer paper now and answer the questions for the analysis. So we're given this equation that relates ym and theta. Y equals p m sine theta plus q. P and q are constants. We need to use our gradient and y-intercept values to determine the values of p and q and give appropriate units. Okay, so the first thing in terms of actually coming up with the units is just note on the left hand side we have y by itself, and y, if you recall, I used the units of meters. So every other term here, separated by a plus or minus, must have the same units. So, or an equals for that matter. So this second term here, overall units should be meters. Overall units for q should be units as well. Should be meters. So we know that the units for q should be meters. M sine theta term there, it's going to take a little more thinking. M sine theta the units for that would be, since m had units of kilograms, sine theta is just a number, so it doesn't have any units, dimensionless. I think that's the right way to say it. Anyway, it doesn't have units. So this has got units of kilograms. Overall, we need to get meters. So if I multiply meters by kilograms and then divide by kilograms, so that's meters per kilogram multiplied by kilograms, that will give me overall meters. So P should have meters per kilogram units. Okay, now what I need to do in order to analyse this, to calculate the values, I need to compare that to y equals mx plus c. Okay, so if on the y-axis I obviously plotted y. On the x-axis I plotted m sine theta of my graph. So y equals y, x equals m sine theta. Whatever is multiplied by x is your gradient, so gradient is equal to p. I actually like to write gradient and y-intercept just in case you have things like m in your equation, so I'm not confusing m with gradient. Gradient is p and y-intercept is equal to q. Okay, so all I need to do is write down those values. The gradient was 0.1593, so that is p, so 0.1593. I'm going to do something with the significant figures here in a minute, and we said that the units had to be meters per kilogram, didn't we, for that? And q is 0.0188 because it's equal to the y-intercept, and the units of that should be meters. Okay, you're not actually going to be asked to you're not actually going to be asked about the significant figures, but I will do something about that. So if I go back to my table, which is not here, it's over here. Okay, so I took, in terms of raw measurements, took this, this and this. So all my raw measurements for the mass were 3 significant figures. Over here, the minimum was 2 significant figures, and these are all to 2 significant figures as well. So the minimum number of significant figures in my raw data is 2. So over here, I should really write these to 2 significant figures. So I'm going to round these here. This should be 0.16 meters per kilogram, and Q should be 0.19 meters. There we go, we have finished that first task with these as my final results, P and Q.